Last speaker is Barney Pell, who I was a little bit of worry he's going to show up at all, but thank you very much, Barney. He's got his PhD from Cambridge, and after that he went and worked at NASA Ames for a number of years, working with a group of people that do model-based reasoning control. You can just take over. I don't And then Barney went to various startups back and forth, including, I guess none of them won, right? Like Whiz-Bang. Well. And then he went back to NASA for a little while, and now he's going to founded a new startup, which I hope will bring in billions. Go to it.
Absolutely. Hi, everyone. Hi, Danny. It's really great to be here, and in fact, it's an honor to be able to honor Danny. I'm gonna plug in the computer in a bit, but actually,
I see. Okay.
Yeah. I'll plug that in a little later. I'm gonna do something kind of unusual in this talk. My story, honoring Danny, is really sort of many more people's story, and in particular, the story of PowerSet. I'm sorry. Okay. Well, my input's here, and I'll be plugging the computer in a little bit. But I appreciate your being keen about this, because that'll. But then if I do it right now, they'll all see what I'm reading from, and that's not the point. So. Okay. And so the reason I'm reading, Ron Kaplan is off right now in Turkey at the Paragram Consortium, doing good work, helping bring sort of multilingual capabilities to the world. And but really, the timing of this, he ought to have been here. Okay. So when I think about sort of the things I really wanted to say, it kind of talks about in the last really few years. But really, the story of bringing natural language to, ultimately to the world that we're trying to do with PowerSet, comes from sort of a long period before that, really starting more than 30 years ago. So, the theme of my talk is bringing natural language to market quickly, 30 years in the making. And actually, I asked Ron for his thoughts since he wasn't here. So Ron basically wrote up thoughts, and it was quite funny because they overlap very well with my thoughts and sort of different perspectives on the same story. So what I'm actually going to do is, I hope it's not too boring, but I'm going to be a conduit here. I'm going to begin with Ron's story in honor of Danny, that he would have done it, if he were here. And then that dovetails very nicely with, my perspective and my story. And then I'll talk about, after this sort of initial starting of PowerSet and then where we are the last few years, show you some, shots and so on of where PowerSet is, because it's a very exciting time to be on the verge of this, capability that 30 years in the making for which Danny has played such a seminal role. So, beginning with Ron's story, I'm going to use the first person, but I'm channeling Ron Kaplan here. I might put some commentary in as appropriate, because some of these themes are just so resonant, I think, for all of us. For Ron, I first met Danny almost 40 years ago. Now, I just turned 40 last week, so I'm definitely younger than Danny. First met Danny almost 40 years ago in 1969, when I was a first-year graduate student, and he was heading up the AI Center at BBN. I was hired to develop an English grammar within the augmented transition network system that Bill Woods had created. And it was my understanding of the benefits and disadvantages of that grammar and framework that eventually led to many of the concepts and insights that underlie today's practical NLP technologies: hierarchical attribute value structures, lexicofunctional grammar, and so on. So Danny was there at the beginning. In fact, he was there before the beginning. Most people in AI are aware of the student program, which Ken has just talked about, that he developed for his thesis, one of the milestones in the early history of the field. But what has been mostly forgotten is a seminal paper from the late 60s that he wrote with Bruce Fraser. It was a very brief paper, but it outlined the basic ideas of network grammars that evolved into Woods' ATN, which evolved into LFG, which evolved into many things and ultimately evolved into PowerSet. This early example illustrates one of Danny's wonderful qualities, his ability to cut to the core of complex problems and to find the essence of a solution. I've seen this many times over the years, how he is able to extract from the details of a situation and figure out what really matters and what doesn't, what two problems have in common and how they differ, which directions are promising, and which will lead to a dead end. This has always impressed me, but I have to say that it has also annoyed me at many times. I can remember several occasions when I was struggling to overcome a really hard obstacle. I would have a whiteboard full of diagrams and formulas, things crossed out and overwritten, marked up in different colors, basically totally confused. Danny would come by, pop his head in, take a quick look, and say something like, "Oh yes, the answer is 5." And he would be exactly right. The answer was 5. Damn. The annoying thing was he could come up with a solution without experiencing the pain of the problem itself. And I needed someone to share the pain just as much as I needed the answer. Now, a funny thing about that anecdote is that I'd also asked Dick, who's also in Turkey right now with Ron, for some thoughts that Dick would share. And so I'm anticipating Dick what was going to be, I think, said again at the open mic. But ironically, Dick told almost exactly that same story, almost word for word. And when I was thinking about what I would have said, the first thing that people would say about working with Danny was pretty much the same thing. And a little thing that makes me happy is that sometimes people have complained about me doing something similar. And so I get to know that although it's sort of annoying that I do that too sometimes, it's a minor reflection of how wonderful Danny can be, if sometimes annoying. So it's okay to be annoying if you're right. Danny left BBN for PARC in the early 70s and in the early days of PARC, and he set about creating a language understanding group. I, Ron, was still a graduate student, finishing my thesis any day now, and I was lucky that he invited me to interview and to become a member of the group. I arrived about 2 years after I accepted the job, still about to finish my thesis any day now. He pushed, he's very good at that, and I finally did finish. So we have Danny to thank for Ron actually finishing his thesis. He also attracted other key people to work in and with the group: Martin Kay, Terry Winograd, Don Norman, Richard Fikes, Ira Goldstein, and others. So many people in the room were attracted here by Danny. Those were great years. We were excited about integrating existing technologies and inventing new ones to build a real language understanding system. We were smart, well-funded, had great computing infrastructure. How hard could it be? We pulled everything together in what was, and what still may be, a state-of-the-art dialogue system. I like how Ron describes this as it was and still actually may be. This is one of the rare fields where something back done 40 years ago or 35 years ago could actually still be one of the state-of-the-art systems. I think many of us have that common feeling. Hopefully that's only going to be true for another 10 years or so, after which they'll all look like they were really early. Anyway, that was called GUS, the Genial Understander System. If you want to take a trip from Palo Alto to San Diego, GUS was the reservation agent system that you wanted to talk to. The best fares and the most convenient schedule on that route. That was our first attempt at integration. What we realized is that there was more work to be done on the individual components, so we decided to back away from integration until we got better individual pieces. Martin and I, Ron, worked on syntax and LFG, and the concepts of unification grammar came out of that, while Danny and Terry focused on knowledge representation and processing, producing one of the earliest knowledge representation systems. We decided we would make another run at a full-fledged system as soon as we locked down the pieces. And that's what we did. The only thing, as everyone knows, is that it took a little bit longer to get the pieces done than we had thought. And there were shifts and changes. Ron forked off a separate group, PARC's Natural Language Theory and Technology area, to work on the language side. Danny continued on the knowledge side with Mark Stefik and others. We all worked on building a Lisp system and launching Xerox's ALI Lisp machine business in the meantime. It's really amazing. I often like to tell the story that when we're talking about the technology legacy that PowerSet inherits from PARC and the kind of people that we're involved in, get to talk about Lisp, Xerox's entire AI business, and the concept of undo. So that's pretty cool. I have some pictures somewhere with Danny and Ron holding up plaques of all their patents and all the rest of it. It's just amazing to look at the whole career development. Anyway, we made a lot of progress. Every now and then over the years, Danny and Ron would get together for a brief status check. Are the pieces done? Are we ready to integrate? The answers were always no and no, but soon and soon. This went on for 25 years or so. And some in management might have heard the answers as never and never. But we were actually advancing. And in fact, 7 or 8 years ago, the answer changed. We were ready. We agreed that finally the integration experiment was worth running again. There was a good chance that we could create something useful and not simply learn that more work was needed. And that's what we did. we defined a common project for the knowledge and language groups, extracting knowledge from textual documents with an eye towards detecting entailment and contradiction. It was challenging and fun, required a lot of strategic thinking. Danny is great at that. Required picking and organizing the right kinds of expertise. Danny was always great at that too. How did that, at least this particular chapter, end? Well, actually, sort of ended, at least right now, with PowerSet. So this is the kind of funny story about where things come in. I'd actually known Danny for quite a while. Some of my own background comes with other people here in the audience, in fact, like David Israel right here. I was an undergrad at Stanford in symbolic systems. Nils over here was my supervisor. So I had my first summer job was at SRI, working in the natural language group with people like David, Jerry Hobbs, Stuart Schieber. So I actually got to see unification grammars as they were coming to be the really hot thing. Later on, I sort of visited and thought about working in Grenoble with Lowry and Annie, and so on. But early on, I was part of another project at SRI that might be sort of then and still one of the state-of-the-art natural language systems on the core language engine. I got a real feeling for what natural language could do from all this work at SRI. It was incredibly exciting, and it really felt like there was an awful lot of work still to do. I made a slightly different decision, which was to kind of go away from the field for a while and let a lot of the rest of the hard work be done so that then it could be, eventually computers would be ready and the hard work be done so we could come back and maybe apply it. I actually had that feeling. It was more than 20 years ago, I guess. And ironically, that wound up happening. So I took a tour through other areas of AI, working in NASA, doing intelligence systems, actually doing some things that overlap with Danny's interests in terms of human agent interaction, how do we talk to robots and these kind of things. And Danny was an advisor to the AI programs at NASA. I always got to see Danny at conferences and always looked forward to talking with him and to his insights. Around 2005, I felt that the time was probably right to look at taking natural language and really having it make an impact in search. I kind of did an analysis of what were the major trends in search, and search becoming such an important market. And by now, I was off had done various startups and had learned a lot on the business side, in addition to in the research world. And so I really felt that with the trends in Moore's Law, meaning that there was so many more computers, as I think David had said about the students' great capabilities, and now we have it on our wristwatch or something along those lines. So much more computing power. Search is becoming so critical in all of our daily lives, and ultimately search is today's starting point for our human-computer interaction. And as we become more experienced and more demanding with search, we just want more. So where was that going to go? Ultimately, the barriers to communication between humans and machines like our search engines was going to be in language. And so to do that, computers would have to understand language on the front end, and then also they have to understand all the content out there at some level so they could match these things. I also thought that language was very well suited to search as an application because you didn't have to be perfect. We're used to right now talking to search engines in terms of a few keywords, which I've called a grunting pigeon language. And it would be great if you could actually just use language like you want. That's a vision that Danny had from the very start, and it was so well articulated in the previous couple talks. So I went around then looking to assess the different natural language groups and technologies and see what was actually ready for application. Was it really possible we were anywhere close? I had done some of my own little prototypes and identified a set of criteria that I thought would really be required if we were going to have natural language work at this large scale. I went around looking at all the groups. So then I was at AAAI 2005 and started talking with Danny. I think we started talking after the On Intelligence talk and kind of ranting a bit mutually about how some people who have moved over from neuroscience and now talking about language don't actually know what symbols are and don't really care, but we really care, and these things, symbols and semantics really matter. And kind of the great irony that the field started with syntax and semantics and knowledge representation, and then there was a period of about a decade where that just dropped off. And in fact, a whole new generation of people entered the field of computational linguistics without actually any knowledge of linguistics or semantics or any of those previous things, having thought that maybe those things were tried and failed. And as Ron pointed out in his comments, well, it was tried and it hadn't failed. The rumors of its failure were kind of greatly exaggerated. In fact, it was just really hard. Not just really hard, but really, really hard. And it took an incredibly long time to get to the point that we're at. And when talking with Danny, he told me this story, which is the flip side of Ron's thing, that actually this PARC technology we've been working on, we think it's ready to go. We think there's still a lot of hard problems, but he told the story of every 5 years, he and Ron would come back and say, are we ready? Are we ready yet? No, there's still more fundamental problems to be solved. Let's go back and work. Every 5 years, more fundamental problems solved. Let's go back and work. And only in the last few years, this is around the 2003, 2004 time period, they came back and said, we think it's ready. We think there's a lot of hard problems, but this is now ready to go. And so came back and told actually PARC management, heads up, we think this is ready. We're in scanning mode. We don't know what the right application is, but let's try to go and figure out. Let's look for it. This is probably the transition. And I'd known a bunch of the people at PARC for a long time and the reputation at PARC, and I'd worked at SRI, and I knew the common ties there. And so I knew the quality of the people, but I had never heard in my entire life, people coming and saying, it's not ready yet, it's not ready yet, there's still more problems. For 30 years, you never hear the combination of that, people being intellectually honest enough to say this isn't actually ready. You never hear that hardly ever at all. And if you do, you hear it from people for whom it's never ready. Okay? And I think this is one of the rare times that I can think of in the history of science, certainly in my own experience, where that's happened. A long period of just hard development, people saying it wasn't ready, and those same people finally coming back and saying it was. So given that I was myself in the mode of looking to say, are we ready now, kind of where is it, that conversation was incredibly pivotal, and we arranged that I think the next week I would be here at PARC. So I came in, and then that started a great series of brainstorming sessions with me and Ron and Danny, talking about what this could mean in the context of search and large-scale search, what language could actually do for search and then ultimately for world, and how this kind of thing could be a stepping stone to ultimately, conversational interfaces and, this language becoming ubiquitous, in our daily lives. And I remember, when I first came in and said, I want to apply this technology to the whole web. Ron and Danny's job basically dropped because they had been used to the challenges of doing 500 sentences on computing, and so used to there not being computing resources. But when we talked about economics and Moore's law and where computers were and where they're going, I was also delighted to realize that there was a key parameter, which was how many CPU seconds it takes to process a single sentence. Now notice that and it had gotten down to 1. Or at least it was very close at the time. And just a few years ago, all the computing on the planet would not have been sufficient to parse the whole web into natural language. And a few years from now, it's going to all be done on your wristwatch. Okay? And right now is this sort of that magic time where things have crossed over and where the economics can now work, both on the cost side because the computing is there, on the technology side because the fundamental groundwork was laid, and on the market side because the application is here, on the revenue side because the advertising revenue from search is so big. So we're really, at this point, Ron and Danny, as we started brainstorming and seeing that this thing could actually work, and the challenge that they worked on the hard challenges, right? So many of the other groups that I looked at and was evaluating had nice showcases, nice examples that they could do, and then you press a little bit and the whole thing falls apart, okay? And so there's no real good way to get from there much farther. It's lots of nice tricks. And that's been one of the complaints about the history of natural language. And that's one of the reasons that a lot of people, when we talk about what we're doing with PowerSet and PARC and this technology, say, oh, God, hasn't natural language been tried? Didn't Ask Jeeves try that? Hasn't that been tried and failed? It never works. And my answer is, well, first of all, Ask Jeeves didn't really have natural language technology. So they showed that people would want to do it if they could, but they didn't really have the technology. And second, this has been really hard. And so by working on the hard problems first, then when you get to the point of real applications, now things can actually become easier. And so when we looked and dove in and pressed hard on PARC, there's on the PARC technology that this group had built, and the knowledge representation and the rest of the foundations, they're just deep, and they go deep and deep and deep all the way down. And that's amazing. So that's what happens when you spend 30 years working on something, and even more than that, thinking about it. And that's the kind of the tradition that really I think Danny brought to all of us, and we're all here recognizing that. It's just very significant. So So I guess it's circling back with some of Ron's words. The story is still unfolding, and Danny is still in the thick of it. 40 years ago, or even 10 years ago, or 5, it wasn't clear what the killer app for natural language technology would be. But we all believed that somewhere, somehow, we would find a pony. And it wasn't clear how we'd structure things to go after the application when it became apparent. We didn't predict PowerSet or search, but here we are, just about to launch a broad-scale natural language search engine. An engine based on the deep natural language and knowledge representation technology that emerged from all those years of research. What a ride and what a great collaboration. And search may be just beginning of the end. In the back of our minds and with PowerSet success, there is still the possibility of building that general understander system, what we would now call a conversational user interface, or a CUI. As Ron concludes his talk here, Gus 2, how hard could it be? Let's get started. So that's the main part of some of the talk. I brought some visuals just to show kind of where we really are now. Do we still have time? A little bit? Okay. There we go. Let's see. That should just recognize. Does it? Do we have this on? Yeah. What do you think? That's actually what happened to my computer now. Oh, maybe I need to plug it in. Is that? Oh, I do? Okay. Oh. Well, let's unplug that for a second. Well, yes, it would seem that my... Well, that was unexpected. Yeah. Yeah, that's unusual. I'm sorry, everyone.
So you display and you mirror so that you'll see the same image on the screen.
Okay.
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 So
Well,
if
I'll.
you reboot, try that.
Okay. Well, I will try. I'll try rebooting, and we'll see how that turns out. But while rebooting, I'll just sort of talk a little more. And some of these things are slides that I would show. And but in any case, it's all good. One of the it's really fun having the PARC and natural language story and kind of actually in a business plan and in sort of the presentations out to the investors. So I'll tell you a few of the things from there. This is how this natural language stuff translates into a business. One of the things that I talk about is the changes in search and how there have been a set of major advances that have happened in search as an industry, and these advances have generally been triggered by an increased level of understanding of the content, creating a new document model. And it's really interesting if you look back. So search is so important, and people today think that what we have is really good. Isn't that going to be the end of everything? What we have with keyword search and and search engines like Google. And I tell a story about just remember back when we used to do hierarchical directory search on engines like Yahoo. You click down, find that page, and that was the most dominant prevailing search technology, information technology, in the early internet. It was how everyone did their work, and we just assumed that was going to be the dominant way that you did it. And now we look back on that and say, remember when we searched using these hierarchical directory structures, and that feels like a thing of the past. Still done in some context, but that's not how we do our normal search. And that's just in a period of less than 10 years that our dominant way has completely shifted. And and then I project forward into the future a bit. Picture ourselves as 5 years or 10 years down. It's about that much, right? It's really not much longer than that. And remember when we used to search using keywords, right? I mean, it's kind of amazing. We're here at that point, and I really think it's inevitable. Remember when we used to take all of our rich human intentions, hopes and dreams, goals that we're trying to accomplish, and distill it down to like a couple of words and put those in the system and hope that we got lucky and it would give us the results we want. Or that's our starting point for then going to do more work afterwards. And we are on the verge of a shift where we're going to be able to use language to interact with these systems. That shift is happening, and there's a nice incremental path. Right? We don't have to be perfect when we first start out. All we have to do is be sort of better and useful than what you could just do today. And then you start getting whole new levels. I think it's going to go from a period where where search used to really suck, and now it doesn't nearly suck as much. It feels pretty good. Okay, we're going to come very soon to the period where natural language search sucks. Okay, it's still better than keyword search. Okay, and that's the really interesting threshold for the market. Because once you have that, we now prefer something, and the pain, we're going to have a whole new level of pain that's going to be introduced. Okay, that's going to be the pain of these systems being smart, but we want them smarter. Okay, they understand language, we want more language understanding. Okay, we experienced this in the early days of getting PowerSet going with PARC and the whole team. Let me also just, while I'm giving this talk, say how amazing, extraordinary it was that I came in with a vision for this, and basically we're working with Ron and Danny and the rest of the PARC team, and I was pre-funding completely. There was no funding for PowerSet yet. It was a vision. It was audacious and ambitious, and the PARC team, with support of Ron and Danny and and the management here, worked on the prototype to prove this could actually work. And actually, as it wound up, it took much longer to get all this stuff really going than we thought. Sort of 18 months before we finally actually had any kind of a deal where PowerSet could be even funding PARC. But during that time, the whole team worked and created this prototype. So it would not have been possible without going not just the early vision, but then the persistence to help a startup get going. And that, I think, shows also just a great level of resilience. But yeah, we're going to have this shift. In one of the early days, I think it was January 2006, we had been so focused on getting the system to be able to do anything at all. Well, all these kind of pieces to integrate. It wasn't a technology problem. It was just the integrating all these components and making it actually work in a search context. We were focused on, like, I think one of our example queries was like, who did IBM acquire? Okay, and there was all this while where no results at all would come back, or or this kind of thing, or totally wrong results, and you couldn't even figure out what version of semantics was in anything, which is also weird. There have not been many companies where you can't remember what version of semantics was in your pipeline, right? So that's actually really speaks to the new state of the art. And then there was this moment when it started answering these questions, and we really just all acknowledged to ourselves, we're seeing something new here for the first time. And then it was very, very short from that point to say, wait, that sentence is about someone that IBM didn't acquire or might have acquired, right? And we actually started realizing we want this thing to be smarter about tense and aspect. And that knowledge was actually there, counterfactuals and modalities. And the good news is all that stuff is actually already there in the core technology. It was going to now be a matter of exposing it. And it may still be a matter of exposing this for the next 5 years or more. But it's an interesting example of what I think is going to be early, where you get these systems, they're useful, and as soon as we have a little bit, we're going to want more. And that little bit more is going to mean that the systems that are better, deeper understanding of natural language, better capabilities to handle semantics and pragmatics and all the rest of the kind of things we've dealt with here in this, this community, are going to make a difference in the market. Better AI, better NLP is going to lead to better products, which is going to lead to more users, it's going to lead to more revenue, and that's going to be this virtuous circle that is going to propel this field ahead faster. Let's see, I've actually now got my computer running, so it will be just a moment more before I can show some of these slides. I'm just noticing Ray over there as well. Hi, Ray. Back, so we have multiple days from SRI and from PARC.
You willing to take a question?
Oh, yeah, absolutely. Love to.
We heard before someone mentioned one of Danny's laws, which is you have to have a model in order to function. And another way to put it is you have to have the knowledge. And knowledge has come out all over these discussions. The last example you just used is an example that I would attribute to the natural language community, which is we ran into this problem, so now we have to know more about tenses. That's just more grammar. What are you going to do for knowledge about all these different areas? Where's the knowledge? What are the knowledge bases that are going to go into making this a success?
Okay, well, I can talk to that. I should have, hopefully when this thing comes up, have a few screenshots that talk to it as well. Okay, so.
F5 or F7, maybe.
There's usually a picture of a monitor on one of the F keys.
I'll get that soon. I'm still sort of booting. I have to do. My system requires me to do multiple convex boots, so we'll wait for that troubleshooting in a moment. I think I'm still booting Windows. I booted my Mac and now I'm booting Windows, so we'll get there. Okay, so the first thing is when I was looking at the requirements for this technology to cross over into large-scale search, one of the key things is actually be minimally dependent on knowledge of the world. Because actually, if you have to know about the world in order to get an application out at a broad scale, a general purpose system, then that's going to be, we got a chicken egg problem there, and we're just not going to get there. Okay, so when I was thinking about the really key requirements to get there for this initial crossover point, okay, it's that it should be able to work based on the knowledge of language, okay, and be able to benefit more from knowledge of the world, but not require knowledge of the world to be initially driving value. So it's one of the really nice things about a search application as opposed to a full knowledge-based question answering application or many other kinds of applications, that as you can succeed in doing a pretty good job of matching the intent of a user from their query to the content that the user is trying to reach while understanding language and preserving the linguistic structure without having understood the world. So we make a distinction between linguistic knowledge, the knowledge of what you have to know in order to understand any words or any kinds of these word relationships, and world knowledge. So the fact that birds fly is probably at that borderline, but it's much more even world knowledge than we're dealing with or that need to deal with in order to have a useful search system. So as one of our examples, if the query is what did IBM acquire, then articles about, you'll see in a search engine there'll be articles about IBM mentioned and Microsoft acquired something. Okay? And the knowledge that actually you can realize that the query is about it's IBM is the one doing the acquiring, and in the text that you've got it's IBM doing the one that's acquiring, however that concept is expressed, you're able to bridge those two without actually much knowledge at all of what it means for someone to acquire anything at all. Okay, so that's also true for basically linguistic entailment and so on. So if you ask, what did IBM acquire, and the text says IBM managed to acquire someone, then it follows from how managed works that IBM did acquire them. Whereas IBM failed to acquire them, it follows from how failed works that IBM didn't acquire them. So there's a whole set of linguistic knowledge that can make these things work without actually understanding much of the world. Now I'm going to show you some examples. I think I'm now almost in business here. I'm going to show you some examples where the system is able to extract knowledge. Let's see. Did these work here? Yeah. Okay. So let's go look. Assuming that this. Oh, what was I supposed to do again on the? Okay. Well, maybe it's.
And there's another, he's underplaying the knowledge because the knowledge of language is about, has some basic knowledge about whether you're talking
I think we might be getting it.
have happened or things that might happen or things that will happen. And that's implicit
Okay, now you
in
need
the
to go to
structure
1024
of the
by
language. So
768
the
resolution.
model is a model of how events go together, participants are there, whether things are actually happening or not happening. There is a model here which is implicit in just the language processing, as opposed to the very specific
Okay, so that's where we are.
So
Okay, and this other one, there's two. Is there not two?
Natural language research, computational natural language research is in exactly the other direction.
Mirror.
That if
Mirror.
the knowledge of the
Yeah, it's
language
good.
is not enough, which is why we have so many
warming.
people
It's warming up.
and almost nothing has been accomplished in natural language
You don't think it's warming up?
The knowledge of language is not enough.
Do you think it's warming up?
Knowledge of the world.
Oh,
I think it's just warming up.
are you running your window?
implicit in the language
I think it might be just
and the
warming
way
up.
the language is used is one cut at some knowledge of the world. You do know about the fact that there's things that happen, things that will happen, and you know
Choose 75 hertz. Choose 75 hertz, the 1024 by 768.
I think that's good enough. I'll leave it. Just leave it like that. So, yeah, I think I'm going to just. No, I think I'll just. I think that'll be okay. I'll be able to talk to it. Okay.
It's not that we don't want it,
Okay.
but the question is this enough to get you past a barrier so that you can do things that are much better? And I think what Barney has been claiming and I think showing is that, in fact, it's significantly better than what you can get.
Yeah, that's right. So, in fact, what will really happen is this is the threshold where some knowledge, largely linguistic knowledge, and then some amount of world knowledge starts being useful. At that point, we'll have more and more people contributing the knowledge, and I'll talk about where some of these things, some of the knowledge actually. Oh. Okay. Good. Great problem solving. Okay. Okay. So a few things here. Okay, so this is showing you a few things from PowerSet. We're basically launching a natural language search engine. I think if I start over here. Okay, so if you were to type into this, who founded Google, then you're getting results right now. It's searching Wikipedia, which is a great storehouse of at least unstructured knowledge. And it's also searching Freebase. And Freebase is a structured knowledge project founded by a product of which is a company founded by Danny Want that many of us know. So we say who founded Google. We're getting over here on the right results which are coming right from the database about Google's founders, and we're mapping the natural language into this semantic query language that Freebase supports and pulling back results that way. This is showing us the unstructured text results. And as you can see here, Google comes back as the first one, and Google was co-founded by Larry Page and Sergey Brin. Now, what's interesting about that is that normally you're used to seeing in a search engine the words in your query being bolded. And here you're actually seeing, first of all, highlighted is where that relevant fact is that matches your query, and you're seeing the actual answers being bolded. Okay? So natural language is helping to completely change the way that we're looking at results and thinking about it. And we go on with more results. Google's co-founder listed over here, Google co-founder Larry Page, and so on.
So is the relation between founder and co-founder considered linguistic language?
That's linguistic.
Okay.
Yeah. That's actually following. A lot of this stuff is generative.
And also the relationship between founded and founder.
Yes, of course.
Yes. No, it's really cool. So there's all these like deverbal constructions in here. So conceptually, destruction of Rome by the barbarians is the same fact as the barbarians destroyed Rome, or Rome was destroyed by the barbarians. So there's all this kind of normalization that comes in. And what that means is that we're dramatically increasing the reach of the kinds of matches that can be done, and the kinds of, leveraging the information that the system has into areas that go beyond. Now,
So what happened if you typed in instead, who cares who founded Google?
If you had typed in who cares, first of all, there's a question of why you would do that. But if you typed in who cares who founded Google, then at some level the system would actually, it knows the difference between who founded Google being a kind of top level structure and that embedded in caring. In fact, we can talk about what did someone say about Bill Clinton. Knows is different from what did Bill Clinton say. It knows that actually it's got to be someone saying something, and it's Bill Clinton is embedded in the aboutness of the statement. But I want to show a few more things before we're out of time. So here's just what Tom Cruise produced. We've got the same kinds of action. This is showing an actual parse of a rather complex sentence from the XLE, and I'm not going to go into the details, but you've got an acquisition event. Microsoft is the object. The subject of the event, the service is over here. These are the kind of diagrams that people like Danny have been drawing for more than 30 years. And now these are actually the underpinnings of a commercial system. Now, this is fun. This is what did Google acquire actually as a database query. So we're asking for the subject is Google, and the object is acquire, and give us back all the results so the subject is Google, the relation is acquire, and give us back all the results. And so it's not even a natural language query, but this is actually a query into a semantic database. And you can see here that we've got Google acquired, Upstartle, JotSpot, various companies, DoubleClick, Picasa, Peakstream, Keyhole, Dulance, YouTube, and so on. And this is actually giving us a list of answers. And as we drill in, we can expand and see the JotSpot. Here's where Google acquired JotSpot, or JotSpot was acquired by Google. Here's where Dulance was acquired by Google. And we can see, now you can drill in and see the actual sentence where it came from. And all of this knowledge is created by the system without any actual understanding of who Google is, who any of these companies are, that they're even companies, or what it means to acquire. So we're actually seeing this kind of knowledge is now in our system that our system uses to match these kind of queries. And it was actually all created by essentially machine reading, similar to what Ken was talking about. That's who Google acquired. Here's everywhere that Britney Spears is an object. Here's if you just say, well, what do you know about Google? And the system says, oh, well, I know that Google provides services, advertising, search, software, maps. Google announces these different kinds of things. Google uses thumbnails and PageRank and Ubuntu. Google acquires something. So acquiring is just one kind of fact, fact that Google knows. Again, all that's coming automatically from the text, and all that's coming largely without any knowledge of actually the workings of the world, just how language works. Here's what the FDA approved, and you get a list of all the drugs and treatments and therapies the FDA approved out of Wikipedia, where there's nothing in our system that knows about the FDA. There's really nothing that knows what it really means to approve except for how approve functions linguistically. I could go on more things. This is what do dinosaurs include. So you can actually create an ontology, or at least a taxonomy of all different types of dinosaurs generated automatically from the text. There's certainly errors in these things, but this is real. This is actually live, and inside our system we have users using this now, and within a relatively near period of time, the world will be out using these things and experiencing what it really means for natural language to change your experience in search. So I think that's about the time to end. And Danny, thanks for helping to make all this happen.
Thank you.